Welcome back to Chapter 14 and 15, Introduction to Inference, Part 8. Now last time we talked about the right-tailed test and why it was called the right-tailed test, the left-tailed test and why it was called the left-tailed test. And now for the two-tailed distribution. What happens here is your sample could either be in the right tail or the left tail. And as you can see, if our sample mean was 11, that would be statistically significant, and that would be probably enough evidence to reject the null hypothesis. Whereas if our mean was 9.8, that's in the left tail, but it seems relatively reasonable. So if our sample mean had been 9.8, that wouldn't be enough evidence to reject the null hypothesis. In other words, it doesn't seem like the mean would have differed. So let's look at a complex example. The wording of the claim determines the structure of the alternative hypothesis. So for example, the label on a can of soda states that the can contains 12 ounces of liquid. So let mu be the mean amount of soda per can. Now, a consumer advocate would be concerned only if the mean content were less than 12 ounces. So when they did hypothesis test, their alternative would be that mu was less than 12. However, the quality control engineer for the soda manufacturer would be concerned if there is too little or too much soda in the can. So in his case, he'd do the alternative of not equaling 12. Now in both cases, the null hypothesis is a statement of no difference between the manufacturer's assertion on the label and the actual mean content of the can. So the null hypothesis is that the mean is 12 ounces. So how do we set up the null and alternative? Well, first you read the problem, right? So in general, to set up the null and alternative, you have to identify the parameter in the claim, typically a mean or proportion for this class, for Stat 250 that is. Step 2, determine the status quo of the parameter to determine the null hypothesis. That's the value assumed to be true unless evidence to the contrary. And the third step was to identify the claim that want evidence for to determine the alternative hypothesis, greater than, less than, or different from the status quo. Now let's look at these three examples, and we're going to set up the hypotheses for these examples. So determine the null and alternative hypothesis in each of the following scenarios. So you might want to stop the tape and try to do this. So in Part A, according to the Statistical Abstract of the United States, the mean standing credit card debt per cardholder was $4,277 several years ago. A consumer credit counselor believes that the mean outstanding credit card debt per cardholder has risen since then. So the null hypothesis would be that mu is 4,277, but we need to test the counselor's claim that the mean has increased from that 4,277. So our alternative is mu is greater than 4,277. Several years ago, 27% of Americans stated that reading was their favorite leisure time activity. A researcher wants to know whether this percentage has declined since then. So it's believed that it is 27%. We're trying to show, or trying to prove, or trying to get enough evidence to show that the proportion has decreased. So the null hypothesis would be the proportion is 0.27 or 27%. The alternative would be the proportion is less than 0.27 or 27%. Part C. According to Yahoo Finance, the average daily volume of Dell computer stock in 2000 was 31.8 million shares. Now, Stock Analyst claims that the stock volume in 2005 is different from the 2000 level. So different clues us into it being a two-tailed test. As you can see from A and B, the word is highlighted to clue you in on whether it was right or left-tailed. Risen, greater than, has increased, that would be a right-tailed test. Declined, less than, has decreased would be left-tailed. And just different doesn't give you any indication of which way. So that's the two-tailed test. So our null hypothesis would be mu equal 31.8, and the alternative would be that mu does not equal 31.8. Now, there are only two possible results from a hypothesis test. If we do not have enough evidence to support the alternative, then we will not reject the null hypothesis. But if we have enough evidence to support the alternative hypothesis, then we will reject the null hypothesis. Now, because the decision to reject or not reject is based on a sample, so it's an incomplete sample, like it's not our population, there is always the possibility of making an incorrect decision. Now we're going to revisit stating the null hypothesis. The statement being tested in a statistical test is called the null hypothesis. The test is designed to assess the strength of evidence against the null hypothesis. Now, usually the null hypothesis is a statement of no effect or no difference, or is a statement of equality. So when performing a hypothesis test, we assume that the null hypothesis is true until we have sufficient evidence against it. This is very much like our legal system. You bear the burden to show proof for guilt. Otherwise, the person is assumed innocent. It's the same thing here. So let's look at stating the hypothesis when we look at the alternative hypothesis. The statement we are trying to find evidence for is called the alternative hypothesis. Now, usually, the alternative hypothesis is a statement of there is no effect, or there is an effect, or there is a difference, or it is a statement of inequality. So the alternative hypothesis should express the hopes or suspicions we bring to the data. It is cheating to first look at the data and then frame the alternative to fit what the data show. So we want to, if we have our question, put the question up, then we take our sample, and then we see how that looks in the null hypothesis, and how it looks will tell us whether to reject or not reject the null hypothesis. So there are two types of errors that could possibly occur during a hypothesis test. Now, along the top is the truth about the population. Either the null hypothesis is really true or it's not, meaning that the alternative is true. Along the vertical there is a decision based on your sample. So what you did in the hypothesis test, that was either you rejected the null hypothesis or you did not reject. I don't like the word accept, but you did not reject the null hypothesis. Now, in that first square, if you rejected the null hypothesis when in fact it was true, that's a type 1 error. If the null hypothesis was true and if the alternative was true and you rejected the null hypothesis, then you didn't do anything wrong. Now, if the null hypothesis was true and you did not reject the null hypothesis, then once again, no error involved there. However, if the alternative was true and you did not reject the null hypothesis, then we have what's called a type 2 error. So a closer look, decision errors, type 1. If we reject H0 when in fact H0 is true, this is a type 1 error. If we decide there is a significant relationship in the population, that is, we reject the null hypothesis. This is an incorrect decision only if the null hypothesis is true. The probability of this incorrect decision is equal to alpha. That is, the probability of a type 1 error equals alpha, and alpha is called our significance level. In practice, typical alphas are 0.01, 0.05, and 0.1. Now, if the null hypothesis is true and alpha equals 0.05, there really is no relationship, and the extremity of the test statistic is due to chance. About 5% of all samples from this population will lead us to wrongly reject chance and conclude significance. Type 2 error, if we fail to reject the null hypothesis when in fact the alternative is true, this is a type 2 error. If we decide not to reject chance and thus allow for the plausibility of the null hypothesis, this is an incorrect decision only if the alternative is true. The probability of this incorrect decision is computed as 1 minus the power of the test. So now we're ready to do a